Hello everybody. Today in this final lesson we're going to look at some of the hardest questions we can have on the normal distribution, and that is what to do when we're asked to find the mean or standard deviation and we're given other information. All right, and the default thing to remember when this happens is you need to convert things to z-scores. Okay, that is going to be our way when we have an unknown mean or standard deviation. Let's get straight into some questions. Okay, we'll do two quick examples and that should be enough for you to do the exercise. So an adult scallop population is known to be normally distributed with a standard deviation of 5.9 grams. If 15% of scallops weigh less than 58.2 grams, find the mean weight of the population. So if we imagine this, we call this distribution an X distribution, and we know it's normal, so we know the shape there. Now we have an unknown mean, but we do know that the standard deviation is 5.9, and we can put some more of information onto our picture because we know that we have 58.2 as being this point here where we've got 15% of them being less than that. So that situation is certainly true. So what we're going to have to do, as I said earlier, is we're going to convert this into a z distribution. So z distribution doesn't have that problem of an unknown mean. We know the mean is 0, standard deviation is 1. But what we need to do is we need to find this point, the quantile right here, which corresponds to the 58.2 over here. So that is when we have this 15% being less than that point. Right? So well, we can do that because we can use the inverse normal button. If we do an inverse normal using our calculator, so we're going to type in that the mean is 0, standard deviation 1, and that p-value is 0.15 with the tail going to the left. We can work that out. It's going to be negative, of course, because we've got a mean of 0, and if we do that, we are going to be having an answer of minus 1.0364. So we can work that out on our calculators. We haven't used any of the prior information yet, but we do know how to map things. If I started off with my x from my x distribution and I took away the mean divided by the standard deviation, it's going to give me that equivalent function, that equivalent section on my z distribution. Well, I have lots of these numbers. I know what it is that I'm mapping. It's the 58.2. Now, I don't know the mean, but I do know the standard deviation, which was 5.9, and I know the result. I know that when I do that, I'm going to get that negative 1.0364 that I found with my inverse normal button. So from here, we should be able to work out the mean that we're missing, right? So if we multiply both sides by 5.9, we're going to have that 58.2 minus the mean u is going to be negative 6.1. If I add my mean and I add the 6.1 to both sides, I'm going to be left with my answer. That mean is going to be 64.3 grams. So in summary, what did we do? We thought about this in terms of a standard normal. We did an inverse normal to find the equivalent quantile. Then we used the standardized normal conversion formula to work out what the mean was. Let's try an even more challenging example now. In this one, we have a missing mean and we have a missing standard deviation. So we've got to find that mean and standard deviation of a normally distributed random variable x if the probability of x being less than 20 is 0.1 and the probability of x being greater than 29 is 0.15. And notice we've got two things we've got to find, but we have more information. We have two pieces of information. So this should help us to work at what we need to work out. So same as last time, let's do some modeling. Let's think about our x, and we are told that we're less than 20 has a probability of 0.1 and greater than greater than 29 is a probability of 0.15. Okay, so that is what we know. We have an unknown mean, unknown standard deviation. Right, then think of the equivalent on our z distribution. where we do know the mean is 0, we do know standard deviation is 1, we can work out, let's just call it Z1 for a moment there, look, that Z1 by doing an inverse normal, and we can work out Z2 as well by doing an inverse normal as well. And just to be clear about this, that Z1, we know that the probability is going to be 0.1, mean 0, standard deviation 1, our tail to the left. On that button, if we press that, we are going to end up with negative 1.282 as our result. And again, for Z2, we're going to say mean is 0, standard deviation 1, probability 0.15 with the tail to the right. And if we press that, we should end up knowing what that is. It's 1.036. So you're getting those from that inverse normal button. So from here, we can set up some equations. Just like in the last example, we know the outcome when we do these mappings, right? They're given to us. So we can create two equations, one for Z1 and one for Z2. So we can say that 20 minus mu over the standard deviation is minus 1.282. We can say that 29 minus the mean divided by the standard deviation is 1.036, right? So I've got one from Z1 and I've got one from Z2. It's that same mapping from one diagram to the other that's helping us to do that. So from here, you probably know what you've got to do. We've got to work this out using simultaneous equations. And of course, this is a calculator question, so we can use that functionality of the calculator to help us out. So I think the best way of doing this is probably to start moving things around and making things look nice. So we could, for example, multiply by the standard deviation in both cases and then add the mean. So if we do that, we're going to get 20 is equal to negative 1.282 times the mean, times the standard deviation plus the mean. And we can also say that 29 is going to be 1.036 times the standard deviation plus the mean. From here, we can use the calculator. We can do a GDC solve, right? Okay, using the Polysmalt application on the calculator, and this will help us get the answer. We can see the mean is, I should say, approximately equal to 25.0, with the standard deviation being approximately equal to 3.88. And we're done. Okay, so just a few questions on this. Okay, have a little go at these. Hopefully you can do these if you follow those examples. Good luck.